So for testing the diodes, we shall be using a low cost multimeter, and these low cost multimeters, as we have discussed earlier, have, apart from the voltage, current, resistance, also a diode measuring range. This is the diode measuring range, and this diode measuring range would help us to check many active components like diodes, LEDs, or transistors even. So we choose the diode range. This is the diode range, and this also is the continuity range. That means checking the continuity. So this is the place we will move our meter to this location and then be ready for checking the many active components. Now if we recall, we had understood that a current flows in this direction, current doesn't flow in this direction, and that is what we call it forward bias diode and reverse bias diode in engineering terms. But actually the current flows this way, current doesn't flow this way. So this is the concept which we will follow for testing the diodes as far as testing is concerned. So this is the situation where we take the red to the anode side and black to the cathode side, and we get some reading. And if we do it this way, just the reverse way, we will not get any reading. And if we look at a diode, there is a white band here. That white band is the cathode and the other side is the anode. So you have to take the red one to the anode side and the black one to the cathode side. If in these two conditions you get any abnormal value, for example here it is showing 1, and if you get some other value here, it indicates that the diode perhaps is defective. We can't 100% say it's defective, but perhaps defective. 99% is defective. Once you connect it in this way and the diode, there is some reading which is coming, then there is some fault in the diode. In some costly multimeters, they are called auto-ranging multimeters. That means there will be no range required as far as the low-cost multimeter is concerned, but voltage, millivolt, buzzer, ohms, diode, milliampere, microampere, like this sort of things are provided, and they are auto-ranging. You don't have to bother about selecting the particular range. They are all auto-ranging multimeters. Whatever it may be, you have to choose the diode mode for checking most of the active components. This is how in some auto-ranging multimeters the reverse bias condition is checked. In reverse bias it should show OL. These are in the auto-ranging multimeters. Now let's come to some light emitting diode. In short we call it LED. They are available in several colors: red, yellow, green, and several sizes also. These are called 5 mm size, these are called 3 mm size. There are 10 mm size also, which is double the size of this, and they are available in certain flat type, round type, short height. So those are the type of LEDs which are available normally in the market. And to identify their anode and cathode position, it's like this. The anode is always a longer leg and cathode is a shorter leg, and it is like this. This side is the anode, longer one. This side is the cathode, the shorter one. And if you look at from its bottom side, there is a flat surface, and that flat surface is always cathode. See, once you mount it on a PCB, perhaps the long leg and short leg will not be seen. You will not be able to know which is long leg and short leg. There are two methods by which you can identify. The flat is the cathode, that is negative side, or there is a bigger, these are all transparent, most of the times transparent, you can see them, whether it's a red LED or a white LED, you can see them, and there is a small one here, there is a bigger one here. The bigger one is always cathode, the smaller one is always anode. So this is how you can identify if you are not able to see which one is longer leg, which one is shorter leg, because it's already soldered on the printed circuit board or any circuit board. So you have to test them like a diode. That means the positive side, the red of the meter, has to come here and the black has to come here. In the process, the LED will slightly glow. Once the LED slightly glows, you will be sure that the LED is in good condition. And when you put the reverse way, that means you put the red one here and black one here, like that we had seen for the diode. That means red one here, black one here. If it is an LED, the LED will not glow. So that is how we got to check the LED for its working condition. If it doesn't glow in either condition, it doesn't show any reading, meaning that the LED is defective. At least some slight glow has to come, very slight glow has to come, and if it is not coming, be sure that the LED is defective. LED goes defective mostly because if the leg is short and then you apply more heat during the soldering. So be careful while handling the soldering for this active component, which is very sensitive to heat. Now next comes the IR diode. IR diode and LED are sometimes confusing. In the sense, IR diodes could be transparent, could be like this, or a transparent as we said, and it sometimes is confusing once you look at the LED, white LED. White LEDs are also transparent, and it is highly confusing to know whether it's a IR diode like this or an LED what we had seen like this. So one has to be careful in testing them properly to understand which one is IR diode and which one is light emitting diode. In order to ensure that, what one has to do is take an IR diode, and as usual they will have a shorter leg and a longer leg, and what one has to do, you have to test it like a diode that we have seen in earlier cases, and the IR diode will show some indication as what we have seen like a diode. As we said, the LED, IR LED, all of them are in the diode category, and they will show some reading. And in the reverse direction, they will not show any reading, it will just show 1 as far as the low cost multimeter is concerned. And in the costly multimeters, as we discussed, it shows OL in case of no conduction, that means in the reverse bias condition. And moreover, it doesn't glow, is because it's a infrared LED and it will not glow. So if the conditions are satisfied, that it is showing some figure in the forward biased condition and not showing anything in the reverse bias condition, this is an infrared diode. So the confusion can be avoided this way, as to verify whether it's an infrared diode or an LED what we had seen earlier, infrared diode or one LED, or an LED like this. Checking a photodiode in a multimeter is not that simple like we have tested the diodes. When you check a photodiode in a multimeter, in either direction, what we have seen here will show nothing. Either in this direction or in this direction, if it is a photodiode, will show nothing. Then how to be sure that whether it is a defective LED or a photodiode? Because almost all of them look similar. For example, one white LED or a little colored LED or a IR diode or a photodiode, all of them look like same. So we have discussed about how to differentiate between the IR diode and a LED. Now we have to try to find out how to differentiate the photodiode amongst these two categories. So you look at a photodiode, actually the peculiarity of this diode is that when light falls on this, it starts conducting in this direction also. only when the light falls on it. So in a multimeter, in a diode test, it will not show from here to here, not here to here, but you have to follow certain tricks to test this photodiode. And the trick is you have to measure it in the diode, in the resistance mode. We know that we have in the multimeter a resistance mode. Go to the resistance mode, select 2000K. This is 200K and select 2000K. And then start measuring it. How? The red one and the black one. The red one should go to the cathode point of the diode. Just the reverse way that we check for a diode. Try to understand. The red one will go to cathode like this. The red one to cathode and black one to the anode. This is shown for a diode, but what we are trying to talk about here is how to check a photodiode. We are not using the diode mode. This is the diode mode. We are not using the diode mode. We are using this mode as far as the photodiode is concerned to check whether it's a photodiode or anything else. So for the photodiode, you will get some reading in this situation also, reverse bias, and some reading when you keep it at 2000K range as far as the resistance is concerned, not in the diode mode as shown here. And what you have to see that if you expose it to light, some light, more light, the reading will increase here. That means, the reading will fall here. And if you block the light here by your finger or your hand or anything, the value here will increase. That means resistance will increase. We are measuring in the resistance mode, not as per the diode mode which is shown here. We are measuring in the resistance mode, and in that resistance mode it has to, once you block the light, it will show higher resistance, and if you allow the light to fall on it, it will show low resistance. And that is how you will try to differentiate between a photodiode and an infrared diode and a LED. It is little tricky, but this is the best way of checking the photodiode. And you can see from the graph here, the light falls, this behaves like a resistor conducting heavily in the reverse bias condition. That means current can flow from here to here. Now next comes how to test transistors. Actually these are called bipolar junction transistors, BJT. In short, many people call it transistor only. And they are available in NPN and PNP. In NPN you have the arrow down, in PNP you have the arrow up at the emitter. And all of them are called base collector emitter. This also is base collector emitter. The only difference is this. If you look at the diode way, you can test it. If you look at the diode way, is this: from base to collector it will conduct as far as NPN is concerned. From base to emitter also it will conduct as far as NPN is concerned. And from collector to emitter it will never conduct, or either from emitter to collector or from collector to emitter it will never conduct. If that is the condition which we see in a diode test as far as we had seen before, then the transistor is okay. If any of this condition is violated, then the transistor is not okay as far as NPN is concerned. As far as PNP is concerned, same thing. The conduction will show from collector to base, also from emitter to base, and no conduction between collector emitter and emitter collector. So that is what is the best method of checking a transistor in the diode mode of the multimeter, which we have just seen before while checking the diodes. And how to identify the leads of a transistor is this way. There is a flat surface, and if you hold the flat surface up, then this side is emitter, this side is base, this side is collector. And this is how you have to identify the emitter base collector of a transistor. A typical transistor BC547, 548, 549, they are all NPN transistors. That means arrow is down at the emitter end. They are all NPN transistors, and you will identify them like this and test them as per the diode combinations which we have discussed just before in the diode mode like this. Remember, this is the only way that you have to test transistors. That means for conduction in NPN from here to here and here to here, that means base to emitter and base to collector and base to emitter, and no conduction between collector emitter, and in the PNP it is emitter to base, collector to base, and no conduction between collector and emitter. This is the only method of checking a transistor. It should be always checked after taking it out from the circuit, or if it's a new transistor, you have to check it this way only. Now comes Zener diodes. See, Zener diodes, the low wattage type, look like this in a glass N capsule with a black band here. It sometimes one gets confused with a diode, and particularly IN4148 and Zener diode, they look same. So it's very difficult to understand whether it's a diode or a Zener diode, and as we know, the Zener diode is like this, is symbol wise, and if you look at the graph wise, it is like this. That means in the after certain voltage in the forward direction and reverse direction, it conducts. Testing a Zener diode in a multimeter is not very simple. One has to take the help of a power supply, and then only it is possible. For example, like this, we take a variable power supply. This is the Zener diode, this is the cathode side, this is the anode side, and it can be tested like a diode. This way it will show like a diode, this way it will not show. So you will get confused whether it's a diode or a Zener diode. So in order to ensure that it's a Zener diode, what you have to do is to differentiate between a diode and a Zener diode. What you have to do, you have to take a power supply and connect some resistance in series, preferably little higher value. It's 100 ohm is shown here. We can take about say 1 kilo ohm also, and then measure the voltage. That means red probe here, black probe here, and if it gives a voltage which is less than the supply voltage. Now, so my supply voltage say is 12 volt, and I get a reading here 6 volts. That indicates that this Zener diode is of 6 volts. Like this, where we have certain arrangements made, a Zener diode of 6.2 volt, and we have used a power supply of 12 volts, and when we operate this, we'll see that this is 12 volt, supply is 12 volt, and since the Zener is 6.2 volts, it roughly shows about 6.18 volts. Now if we replace this by a diode, what we will get? We will get the supply voltage itself, because in the reverse bias condition the diode is not going to conduct. Let's see that. So we remove this, we take a normal diode and we connect it here in the reverse bias condition, and what we get the same voltage because it is not conducting. So that is how we can find out whether it's a Zener diode or a diode. That means if I have to go for a Zener diode, I have to use a voltage source which should be higher than the Zener diode. For example, since I am not very sure as to what is the voltage rating of the Zener diode, suppose, then we can take a voltage source of about say 30 volts. Like for example, if I now change this voltage source to about say 30 volts or say 33 volts, and I operate this, I'll get the same reading of marginally little higher. Instead of 6.12, it is 6.32. So whether I use a 6.2 volt Zener diode here, if I use an 8 volt Zener diode, I'll get 8 volt here. But that's how we have seen that by using in this place a Zener diode, and if it reaches the same voltage, then it's a diode, and if it gives a lesser voltage of the supply voltage, then it's a Zener diode of that voltage. So that is why what we said, that the Zener diode can be with a variable voltage or a variable power supply. With a series resistor, you can check the Zener diode. Now with the Mosfet, it is difficult to test it in a multimeter, and Mosfets, as we know, are available in N channel and P channel, and most popular being the N channel. This is called gate, and this is called source, and this is called drain. And for testing it, put the multimeter red here, black here. If it shows low resistance, it is okay. In the reverse, it should show very high resistance. But in both the cases, if the value says so same, or it shows very low value, then in that case it is sorted. That means gate to source is sorted. That means it is gone bad or defective. And for a silicon control rectifier, we call it SCR. Normally they look like this, these small capacitive ones. This is the cathode, this is the anode, this is the gate. Anode, gate, cathode. We call it T220 package. The package is, of course, is immaterial as far as understanding is concerned. They are also available in this type. They are also available in this type. They are also available in module type. There are two SCRs in one based on certain typical applications. And the leads in the smaller types also are like this, where there are small transistors like item is also an SCR. And as far as the testing of the SCR is concerned, the process that is to be followed is this. First, what you do, you put your anode, that the red one, this side, and cathode, the black one, this side, and temporarily sort the gate and the anode. So some little current will flow from the positive, because they will be sorted. Some little current will flow from here to here. In the process, this will continue to show as a conduction, even if you remove the gate. Let me repeat it again. You have the connection like this. Connect the gate terminal with a wire or anything, or with a resistance even. Just connect between here to here. So what happens? The gate gets triggered. And then remove this gate connection. It will behave like a diode. It conducts like a diode. Let's see this. We have a DC power supply. We have a switch to momentarily break the supply, and we have a switch connected to the gate, and this is the SCR. This we will discuss separately. And when we just trigger the gate, that means I just push it and release it, the lamp continues to glow. This lamp continues to glow because this behaves like a diode. After it is being triggered and the gate is removed, it behaves like a diode. And when will it stop? When either I stop the current here momentarily and then bring it back again, then the current stops. Again it has to be triggered so that it starts. Or there is another method where I apply a reverse voltage across the cathode and the anode. Then also the current will stop. Because the gate triggering has been already made, the current, the SCR is already conducting, and it can only stop either by this, that means breaking the supply momentarily, or by applying a reverse voltage across the cathode anode like this. So this is how the SCR operates, and the testing method, as we have discussed, has to be followed in that way. Like this what we discussed. Connect the red probe here, connect the black probe here of the multimeter in the ohms range. It has to be in the ohms range, that means some current has to flow, and then connect this point to this point. It should continue showing. And to find out which one is cathode anode gate, this has been already explained, and this process has to be followed for testing the SCR. Next comes the Triac, which is a bidirectional AC switch, and it has a gate like an SCR. And if you look at the comparison, this is the Triac. This is what the Triac symbol looks like, and they have this type of arrangements where you can identify which one is the anode cathode gate. That is 1, 2, 3. This is terminal 1. Center always, that means this one, center is always M2, and the first one is always M1. The first one is always M1. This is always M1. When you hold it like this, this is M1, this is the M2 or A1, A2, and this is the gate. To identify that is this process, you can follow the same principle as to how we check the SCR. Because this is a bidirectional device, by sorting the gate to one of the points in the M1, it will conduct, and once you break it, connect it again, it will not conduct. So the process is slightly complicated, but it has to be only done in that way, otherwise it is not very easy to check. Next we can talk about an component called Opto Isolator or optocoupler. Here it's a 6-pin IC. We have pin number 1 and 2 as a diode, a light emitting diode, and this throws light on this, and this conducts between 4 and 5. This is available in the transistor version like this, and the other type, or you can see it like this, or the other type which is available in the Opto Isolator is the Opto and Diac combination, which is used in very places in the power electronic sector. This is pin number 1 and 2, and 4 and 6 are used, 5 is not used. And this looks like this, is a 6-pin IC, and they are very popular as far as the firing angle control is concerned, and the pin configuration is again like this. Testing of course is a bit difficult. It's all that one can test is the diode point. Every Opto Isolator pin number 1 and 2 is the diode, and you can just see the continuity between 1 and 2, and it should not conduct between 2 and 1. That is the only thing that one can do as per the testing of the Opto Diac or Opto Isolator, Opto Transistor is concerned, and testing this side is comparatively difficult, and it's only can be tested at the circuit level. The other component is called a Diac, and the Diac is a bidirectional device. It conducts in both directions. It looks like a very small tiny component like this. Symbol is like this, and they are always rated with a particular voltage, and if it crosses that voltage only it conducts, like a diode in both directions. Diode doesn't conduct in both directions. This conducts in this direction, this conducts in this direction also, provided the voltage level which is at which it is manufactured crosses that level, and that is what the Diac is. And it's not easy to check the diode in terms of its in a simple multimeter.